Hi, this is Team Glowing Darkness from the NASA Apps Challenge. Our challenge was to try to simulate any 3D object to its corresponding light curve. And we created this GUI that you can model your own 3D object from here, or you can choose from the gallery, which have real asteroid shapes. We can choose for now Cleopatra. Let's load it here. And the second tab is the tab for the light curve datas, the database. And you can retrieve almost any asteroid shape that you want. Just know the number. Here it corresponds to different dates. Let's choose the second one. Okay, now the third tab is for the settings. The first one here is the object settings. You can choose the orbit that is rotating at, the angular velocity. The second tab is for the camera settings. We will keep it the same for now, and the light would be directional for sunlight. Simulation settings, time and time step. Let's keep it here the same. And finally, we have the inertia stability, and this is very useful to predict at which axis the asteroid is rotating at. So if we just guess from here without scientific knowledge, let's say it is rotating about the x-axis without even knowing, and let's test the data. So this is what we are getting for now. We may be correct about this or not, so we're not sure yet. Okay, after the simulation is done, you can press this button to retrieve the observed values and then normalize these two. You will get these two shapes. The blue one is the simulated one. And you can see that they don't correspond to each other. So basically, it either means that our simulation is wrong or we're doing the wrong axis. And the best way to figure out which axis it is rotating at to find the inertia tensor. So asteroids usually rotate about the maximum inertia, and we can test it here. So let's try the first axis. This is not stable because this is not the maximum inertia axis. But if we try the y-axis, let's see if it will be the same. It is still the same. That means that the stable axis actually is the z-axis. And let's do it here. So let's play it. And actually you can see here the 3D model. So basically this means that Cleopatra in reality would rotate this way, in this direction, which is quite cool. Without even knowing or seeing the object, you can know which axis it is rotating at. Okay, this is the new shape that we're getting. Okay, let's press the observe button, normalize the two data. Let's see. Okay, nice. As you can see, now the two data correspond better because, as I said, Cleopatra in reality rotates about the z-axis, as we see here. So this is the basic idea behind our simulation, and I hope that you can find it useful. And if you need any help, you can find the GitHub link in the description. Thank you.